You know what, I'll have to call you back later. I'm sorry, I have way too many reports to look at right now. Oh my goodness, all this data is unorganized, uncategorized. I can't visualize trends, and on top of that, it's taking me way too much time. I still have to go home and feed my kids. What am I gonna do? What if there was some kind of data visualization that used a categorization algorithm and machine learning to organize all this data so I don't have to spend my entire morning organizing the information with Post-it notes? Who is it? It's you with glasses. It's me. Yes, and do I have the solution for you? I am very excited to present the BART OCC Shift Manager Log Visualization.
Hi everyone, my name is Lean.
Hi, I'm Hannah, and this is our solution to the problem you just witnessed.
So our goal with this was to create an application that BART managers would use to get a synopsis of the dense daily operation reports that they get every morning. One of the components for our visualization was called a swim lane diagram. So before we go into the demo, I'll just give a little introduction of this. So the power of the swim lane diagram lies in the fact that it is able to reveal redundancy and inefficiency in a system. So it would show you, for example, how multiple departments are focusing on the same thing, and you'd be able to see this through the arrows that lead from one event to the next. And this aids in a reduction of work, reduction of cost, saves money and time, and those are important factors, right? So swim lane diagrams also help viewers grasp a bigger picture, again, as one event leads to the next. And also for our visualization, we wanted it to have a hover state, so when the BART manager puts their mouse over the event, it would be able to give a greater description of what was occurring.
And for similar reasons, we also decided it would be useful to have a geographical visualization of all the incidents that happen in a day. In this graphic, we plotted the BART tracks and used markers to point out the incidents at the location that they occurred. There's also a time scroller in this graphic that corresponds to the time of each incident. So as you scroll the bar, you see the incidents that have happened up to that point in the day. And as you can see here, this was our plan for how this visualization would look. Now for a demo of the data visualization. This is the test table that we worked with. You can see here that we have columns for time, log, and location of the incident. Then based on the location, we combined this table with the proper X and Y values to superimpose the incident markers on the image of the BART tracks. Then we utilized IPython widgets and Matplotlib to make a marker for each incident in the table. Each incident had a corresponding time, and as you use the time scroller, it shows the incidents up to that point. So you can see here.
As you drag your cursor across the timeline, the events begin to pop up in their respective location. The final version of this will use different symbols and have a hover state.
Here we have our next visual, our swim lane chart. Here you can see that this is again the test data from before, but now it has a generated column for the category of the specific incident. And these categories are generated by the machine learning model. So as I scroll down, then you can see that we utilize Python packages to create a time axis for our swim lane chart. Then we use Plotly to plot each incident based on the category type. And here is the swim lane chart that we produced based on the test data. You can see that it comes with a legend for the icons. And also when you hover over the specific markers on the swim lane chart, you can see its log and location details show up as well for each incident. You can see here, for example, this happened around 7:53 a.m. You see the category is unhoused, and you can see the log entry.
And now that you'll have seen a demo of our vision, we would like to walk you through the process and still what we have left to tackle. So, starting in September, getting started, we were brainstorming the solution. We created a prototype using Figma, and we also started to break down details of the specific diagrams we wanted to use, for example. In October, it was lots of Jupyter Notebook and idea revision. Some things that we started with didn't make the cut. And then in November, which just finished, the data visualization team and machine learning team, we collaborated to start to put our work together so we could create the final version.
But then in December, just recently, we fully integrated the machine learning model with the data visualization work to generate the data sets that the visualizations would be using, and development for the web application started. For future improvements, we definitely want to incorporate an upload feature to upload log tables to the web application as CSV files, so then that can generate the data visualizations itself. We also want to have more incident details pop up when hovering over the geographical visualization, just to give managers a better way to visualize trends on maybe geographical aspects of the incidents for a day. We hope to make this a fully fleshed out and functional tool so that BART managers can use this daily and make their work more efficient.
Hi everyone, my name is Rebel.
And I'm Jason.
And today we're going to go over the machine learning aspect of our project. So one of the first parts that we had to go over while starting this project was seeing what cloud computing service we want to utilize in order to host our project. And we decided to go with Microsoft Azure as a development platform, utilizing our free student credit because they had a number of great advantages, such as the pre-installed data science libraries, Jupyter Notebook, and it was very accessible and it was very easy to change the VM size based on compute needs. And we were able to share our code with each other utilizing a GitHub repository with GitHub. So starting our brainstorming with the project, there was a lot of information that we kind of had to hone down and a lot of concepts that we thought about before making our machine learning model. So some of the many concepts that we used or thought about initially were one-hot encoding, word embeddings, logistic regression, random forest, neural networks, supervised versus unsupervised learning, and utilizing larger data sets. Each one of these concepts had a number of pros, a number of cons, but essentially what we wanted to do is run a defined data set such that it could be automated and that our results would be accurate. So some of the challenges that we initially faced whilst doing this data processing was the formatting of the data that we were given, the inconsistency in terms of formatting, the difficult understanding of the logs, since there was a lot of lingo that we did not understand and the no predefined labels. So we had to do a number of research and cleaning up of this data set before actually putting it into our running code. And so one concept we kind of wanted to go over in terms of how we utilize classification was one-hot encoding and word embeddings. So in a nutshell, one-hot encoding essentially will run a value against a data set. And if the value matches a value in the data set, it is assigned with 1, otherwise 0. And four-dimensional embedding will essentially run a word against values in a data set and produce a vector that corresponds to the similarity of that word with that value. And it's very helpful because we were able to graph all of these words after, and they would graph them based on the values of those vectors. So we could that would help us in terms of classification.
All right, and now I will go over some our model architecture and some of our design choices. First of all, we decided to go with a supervised learning approach because we felt that any categories produced by an unsupervised learning approach would not be useful to our end users, which are the BART operation controllers. And so the first step to our model was to vectorize the text using word embeddings. So to do that, we first built up a vocabulary of the most common words and then randomly assigned each word a word embedding, which would be trained later on through the neural network. After we convert each word to its word embeddings, we take the average of it to help account for variable input lengths, and we feed it through our through the hidden layers of our neural network, where most of the learning and discovering of relationships happens. And then we take the output of that and put it through a softmax function to normalize the probabilities so that they all add up to 1, which makes working with the output data much easier. And then some libraries that we mainly used TensorFlow to build our neural network. sklearn and pandas also we used to explore some features and organize our data. And as you can see on the left, that's our code or model in code form. To evaluate our model, we mainly looked at accuracy, although there are other metrics we could have used. We believe accuracy is a pretty good metric because there were 13 different categories. So yeah. But even with this, we only had a training size of 500 because we decided to go with the supervised learning approach. And getting accuracy this high is pretty good. And to help combat overfitting, we implemented k-fold cross-validation and L2 regularization. And then some ideas for future improvements for a model. If we wanted to explore more unsupervised learning approaches, we would have to test different clustering algorithms to see if the categories generated could be useful. And then if we want to explore supervised learning more, we would have to work with the end users to generate more manually created data to help train our model and make it more complex. And one issue with our model right now is that it does not take into account word position and context. So an easy way to improve it is to implement models that do take into account position and context. And some examples of these are Word2Vec, CNNs, which are convolutional neural networks, RNNs, recurrent neural networks, transformers, which use an idea called attention, which directs the neural network to look at certain words more than others. And then, yeah.
Wow, I now have this amazing data visualization tool. I can't wait to use it every day. Thanks, Dream Team.